All right, let's jump right in. When we think about these massive industrial projects or maybe a sprawling data center, our minds go straight to the big stuff, the giant machines, the racks of servers. But what's holding it all together? What's routing all that power and data? Well, it's the humble cable tray. It really is the unseen backbone. And believe it or not, choosing the right one is one of the most critical decisions you can possibly make.
So you're looking at your options. You've got ladder trays, you've got perforated trays. I mean, they both hold cables, right? How much of a difference could there possibly be? Well, as we're about to find out, that choice, it can be the difference between a system that runs flawlessly for 30 years and one that's just plagued with problems. So yeah, it really, really matters.
So here's what we're going to cover in this explainer. First, we'll talk about why this is such a critical choice. Then we'll get into the nuts and bolts, the anatomy of both ladder and perforated trays. After that, we'll connect their structure directly to their strength. And we'll wrap it all up with a really simple framework for making the right call for your project. Okay, let's get into it. Section 1, the critical choice. You know what? That word cascades on the screen is just perfect, because this is not a small, isolated decision. It literally affects everything that comes after it: your budget, the long-term reliability of your system for decades to come, and maybe most importantly, the actual health and performance of the cables themselves. Now, at a glance, the choice looks pretty straightforward. On one side, you've got the ladder cable tray. Think of it as the heavyweight champion, built for those really demanding, heavy-duty power applications. And on the other side, you have the perforated tray, which is more for your general, lighter cable management. But as always, the real engineering magic is in the details. So how do you choose? Well, it's not a gut feeling. It all boils down to 3 core engineering factors. First, what's the total weight of the cables you need to support? That's your load capacity. Second, how much heat are those cables going to generate? And how important is airflow for getting that heat away? And third, what kind of environment is this tray actually going to be living in for the next 20 or 30 years? All right, let's move on and really dig into how these things are built. We'll start with the anatomy of a ladder tray. And if you remember one thing from this section, make it this phrase: I-beam-like geometry. Because that simple design concept, well, that's where all of its incredible strength comes from. So this table here breaks it all down. It's actually pretty simple. You've got 2 main side rails, and for heavy-duty trays, we're talking about thick 2.5 to 3.0 millimeter steel with rail heights of 100 to 150 millimeters. These act just like the top and bottom of an I-beam. They take on all the primary bending force. And then, connecting them, you have the rungs, which is what the cables actually rest on. It's this specific geometry that gives it that amazing load-to-weight ratio. And within that design, the really crucial variable becomes the spacing of those rungs. If you go with 150 millimeter spacing, you're getting more support points for your cables, which is fantastic for reducing stress. But if you opt for the wider 300 millimeter spacing, you're cutting down on the overall weight of the tray itself. It's a classic engineering trade-off, really: support versus efficiency. Okay, now let's switch gears and look at the anatomy of a perforated tray. So if the ladder tray is like an I-beam, the best way to think about a perforated tray's base is as a flat plate. And structurally, that is a completely different ballgame. I mean, you can just see the difference right away. The base of a perforated tray is mostly a solid sheet of metal. About 30 to 50% of that surface is then punched out with these holes. Now, those perforations are there for a reason. They reduce weight and they do allow for some ventilation, but at its heart, the structure is still a continuous surface. And this design, this continuous sheet, usually between 1 and 2 millimeters thick, it has one huge advantage. It provides perfectly uniform support across the entire bottom. This makes it absolutely ideal for managing a whole bunch of small diameter cables or bundled wires that might otherwise sag or fall between the rungs of a ladder tray. All right, section 4. This is where the rubber meets the road. We've looked at how they're built. Now let's connect that geometry directly to what they can actually do out in the field. And this quote from our source material just says it all, doesn't it? Because that perforated tray base acts like a flat plate, it's just inherently less efficient at resisting bending forces. It's physics. And that's compared to the deep, rigid structure of a ladder tray. This directly translates to how much weight it can hold and how far you can span it between supports.
And the numbers, wow, the numbers really make this difference crystal clear. A heavy-duty lauder tray, what we call an IEC Class C or even Class D, is rated to carry anywhere from 75 to a whopping 200 kilograms per meter. Now, that's not just some abstract number. That rating is what guarantees your main power cables will stay within their strict deflection limits over a 25 or 30-year service life. In fact, a 2023 project in Ningbo used this exact class of tray and managed to keep the midspan deflection at just 6 millimeters, even while carrying a 180 kilogram per meter load. That's performance.
Now, compare that to the perforated tray. Its load capacity typically tops out right around 75 kilograms per meter, and a lot of them are really in that 25 to 50 range. Look, it's still a strong piece of equipment, but it's just playing in a completely different league. The right choice here depends entirely on what your project demands. Which brings us to our final section. Let's pull all of this together into a simple, straightforward framework so you can walk away knowing exactly how to make the right decision. It really just comes back to those 3 core factors we talked about at the beginning, but now we can frame them as a clear process. Step 1, calculate your required load. Are you running those heavy medium voltage power cables that need 150 kilograms per meter capacity? Or are you just running lighter data lines? Step 2, think really hard about airflow and cable type. And step 3, analyze that installation environment. Let's just focus on that airflow piece for a second, because it is so critical for the long-term health of your cables. You see, ampacity is the max current a cable can handle before it overheats, and the open design of a ladder tray is king for allowing free air to cool things down. Now, here's why that matters so much. According to what's called the Arrhenius aging model, for every 10 degrees Celsius a cable operates above its temperature rating, you cut its insulation service life in half. A 50% reduction. That is a massive long-term risk and a potentially astronomical cost down the line. So we'll end on this question. The choice between a ladder and a perforated tray, it isn't just a technical spec on a project sheet. It's a strategic decision. It really forces you to ask yourself, am I just engineering a solution for the cables I have right now? Or am I building a robust, reliable backbone that has the capacity and the resilience to handle the demands of tomorrow?